And this is a very exciting Skype call that we're on. I'm with Ben Hedrick, who's the lead for AP Calculus. What do you do at the College Board?
Really anything with AP Calculus and AP Statistics is something that I have a little bit of control over. So for example, for AP Calculus, anything with the curriculum, anything with the assessment is something that I work with.
And I'm sure that you're as excited as I am, and you know, several hundred thousands of students are around the country for the AP exams that are coming up in roughly a little less than a week. And I thought a fun place to start would be when you guys write a test. What are you trying to assess? What's kind of the spirit of the questions, both on the multiple choice and the free response section?
So what we're looking for from students is evidence of good conceptual understanding of calculus. Now, we have some things that are going to test procedures, but really we want students to understand what's going on with the calculus rather than just calculating things or putting numbers on paper. A lot of thinking questions, a lot of insight to make sure that whatever good calculus those students have learned in their courses, we're assessing on the AP exam.
And you know, I've done a bunch of example problems for the AP exam. And yeah, my sense of it is you sometimes will do some of the minutia work, or you'll give the formula, and you're really trying to understand whether students understand the essence of what an integral is, or the essence of, you know, derivative as a rate of change, or the slope of a tangent line. So if you were preparing for this exam, if you were one of these students, what would you suggest to them? You know, obviously we have a little less than a week for this current test, so what advice would you have for those students? And then just generally, as students go through the year, how should they think about it?
Yeah, the advice I would give is dependent on how much time the students have to prepare. So the advice that I give at the beginning of the year is different from the advice that I give now, several days before the exam. Getting ready for it, first relax. You know, this is a calculus exam. We're not going to be throwing anything at you from left field. It's calculus. You need to know limits. You need to know derivatives. You need to know integrals. In terms of preparation, you know, make sure you're taking the time to review the basics. Every question that they see is going to hit one of those big topics. So make sure you know your derivative rules. Make sure you know your integral rules. Take a look at the old exams and see how we're asking questions. And to look at the patterns and see that we're always asking about understanding what a derivative means, understanding integration and the idea of accumulation. There are no secrets on the exam, so really stick with what we've done. Make sure that you're thinking of ways to apply your good knowledge, and just review your basics.
And my experience with the exam is there's a lot of, as you just said, really the mainstream meaty topics, you know, chain rule, fundamental theorem or theorems of calculus, things like that. What's your sense of the more, what I would consider maybe a little bit more of the minutia, some of the more special case derivatives or special case integrals, you know, arc, tangent, how much does that play into the exam?
You know, I think Saul, you've actually answered your question in asking that. It is the minutia. So really, at this point in time, if you're getting ready for the exam, spending time on the minutia is not where you're going to be best served your time. You should be getting the major things, and you said it right at the beginning, chain rule. I mean, any kind of question you do with derivatives, you know, if you're doing maxes or mins, if you're doing tangent lines, if you're doing a related rates problem, they're all derivatives. And if you're having trouble with the chain rule, it doesn't matter how much minutia you spend your time with, the chain rule is going to come up. So I would say don't sweat the minutia. There might be something on the exam that you haven't reviewed as much as you want to, but it's going to be one single solitary question. Basic derivatives are going to form the basis for all those problems. So that's where your time is best spent.
Yeah, I definitely get that sense, especially, you know, how do you interpret the first, second, you know, derivatives, concavity, things like that. Those seem to show up a lot. But once again, that's the conceptual idea of derivatives. And on the integration side, I've been doing a bunch of the free response. It just seems like, I mean, you know, what happens if you swap the bounds of integration, or if you add integrals and things. So a lot of the properties and the conceptual understanding of what an integral is, but, you know, not necessarily like the fancy tricks, at least at this point, if you're studying.
Absolutely. There's nothing that we go after the fancy tricks. We're not trying to ask trick questions or play the gotcha moments on it. It's really an assessment of calculus. And for the students who've been going through these great courses all year, this is a wonderful opportunity to show us everything that you know and get a really great score on the exam.
And what about calculator? I mean, I was doing some of the free response. That first part of the free response, knowing your calculator well helps.
Oh, absolutely. The calculator is a tool, and like any tool, you want to make sure that you're applying it appropriately and strategically, which sometimes means using your calculator and using it well and correctly, but other times not using your calculator. I mean, even on the free response section where the calculator is being used, we expect students to show their work. If you're taking an integral, we want to see that you've actually taken that integral. Now, the calculator will do the work of it, but we want to see the notation that says this is the integral you calculated, and this is the answer you obtained. And then do whatever you will with that answer as required by the question. But good communication through writing, even on the calculator section, is necessary.
Yeah. And for students taking the BC exam, above and beyond the core differentiation, integration, a lot of what you learn about parametric equations is actually just an extension of what you learn in differentiation integration. But probably some of the convergence tests are something to become pretty familiar with.
That would be correct, yes.
And in terms of grading of the exam, some people to get a 5 or a high. My understanding is you don't need to answer absolutely every question perfectly.
Well, like any test, if you want to do well, you don't have to have perfection on it. And this is a test where students are coming in, and it's a 3-hour time test, well, a little over 3-hour time test. And you can do a lot of really good work and earn a 5 pretty easily. So I wouldn't tell anyone to go in there worrying about trying to figure out what magical numbers they need to get in order to get a perfect score on the test or to get a 5 on the test or whatever it is they're going for. Just go in like you would on any test, do your best on every question, get every point that you can, and hopefully it'll work out fine for you.
What advice would you have for students, especially on the free response where there's multiple sections, and if on part A they say, hey, well that's I don't get what that part, what should they skip to the next free? What should they do?
I actually have a very common advice on that one, and that's to make sure that students are trying every part of the free response question. One of the misconceptions students have is exactly what you said. You hit part A and you're freaking out a little bit because you don't know what part A is about. That's okay, move on to part B. There are some questions where the answer for part B depends on part A, but for the majority of the questions, they're separate pieces. So part A, part B, part C, if there's a part D, they might all be asking very different things. And if you have trouble even with part C, that doesn't mean that the question gets progressively more difficult. Give part D a try. And a lot of the things that we do give points for are good, solid calculus work. So if you can set up a problem, maybe you don't have time to finish it, maybe you make some mistakes along the way, the answer point is only one little point out of 9. There are other points that set up in the conceptual understanding of the problem. And a lot of students have good conceptual understanding that they could set up, pick up a point here, pick up a point there, but they panic a little bit and they move on to another question and never come back. And that's okay if you want to move on to another question, but absolutely I would say if you're having trouble with part A, that's all right. Take a look at part B.
And one thing that I've observed is a lot of these questions at first when you look at them like, oh wow, this looks like some really super deep thing, but it really is some core basic calculus ideas. And that if you're on the right track, it's actually quite simple. So if, would you say it's fair if a student finds themselves doing a very hairy calculation that they might question whether they need to?
I would go beyond might. They should question what they're doing. If you've done something where you feel like you need to prove a new calculus theorem in order to answer it, something has gone terribly, terribly wrong. And also if you feel like you need to bring in some sort of mathematics you've never seen before in calculus. I mean, as much as I hate to say it, this is calculus, it's limits, it's derivatives, it's integrals. Even though there's a lot of wealth in that one, if you're doing something beyond that, probably something has gone wrong.
Yeah. Well, thanks. I think thousands of AP students are going to really appreciate that. Any other kind of parting words for the coming test?
It's the same thing that I used to tell my students when I was teaching AP calculus. This is just another test. And the beauty of AP is the teachers have been prepping their students since the beginning of the year. It's one of the few tests where everyone knows what's coming. So when you sit down and you've got free response questions, you've got multiple choice questions, there really shouldn't be any surprises. This is the stuff they've seen all year. They know what to do. Take a moment, take a breath, take a look at the problem, get all the points that you can to show us that good calculus.
Awesome. And I'll throw in a plug. We have tons of resources for the students as well. And we're going to have our office hours on Monday. So super exciting. Thanks a bunch, Ben.
No, thanks for having me.
What you mentioned, the office hours, I actually haven't, in all my free time, had a chance to figure out if they're doing it again this year, but that was the night before the exam. They were doing office hours. They were taking questions live from students. They were throwing in some that they thought were good as well, going through FRQs the night before. Anyway, pretty cool. And coming back, some of you are like, no, he's lying, they do try to trick us. They give you answers showing, demonstrating common mistakes made in calculus. Is that tricky, or is that just not making the answers 1, 2, 5.3, 6, 7, 9, 10, 11? Like, you know, I don't know. Bad math skills. They're trying to give you possible answers that you would actually get. Besides that, to be honest, as he said, it's pretty straightforward as far as what you are going to see if you can become familiar with the different types of problems. There were a few things on the new exam that was for last year, which was very much like it was just the same old from quite a while, or that had been in effect for quite a while. What's different this year, you guys have 30 instead of 28 questions, which is what you saw on Saturday. So you're not even used to the 28 question format per se. You had 15 instead of 17 on the calculator, which once again, you're not necessarily used to the 17 questions, so it doesn't really make that much of a difference. And you guys got a taste of what they are showing is their a little bit deeper emphasis, a little bit more emphasis on the concepts and not just the problem solving. So like, I think it was the last question, was it number 30? On the, no, not the B's, on the non-calculator multiple choice, was that the one where all you had to know was the integral definition of the limit notation? Yeah. Like, there was no solving. It was, hey, it's an integral. Cool. You know, like there was nothing to do. It was purely concept. Like that's the easiest-ish. Now, it doesn't mean you got it right or wrong. Maybe some of you weren't ready for that. But that was one of the easiest multiple choice questions I've ever seen on an AP calculus test. So they are maybe throwing in a little bit more concepty ones this year rather than just problem solving. But otherwise, there's going to be a table, at least 1 or 10. There's going to be a graph, at least 1 or 10. There's going to be functions given to you representing rate or representing original quantities or amounts. There's going to be motion. There's going to be related rates. So anyway, there's going to be a slope field somewhere, either on the FRQ or like a multiple choice matching thing above. There's probably going to be a solve the differential equation, which is what we're going to talk about lead into right now. So I just wanted to give you guys that idea. Now, once again, that was a week before the exam last year. How much time do we have? A month. So when you talk about the minutia, we're going to talk about some of the minutia. We're not just going to ignore it. We're going to talk about some of the things they're going to try to trick you on. But the most important thing is, do you have an understanding of the general calculus, what the relationship is between limits and derivatives and integration, and how to solve them in their different applications? And then, yeah, there are some funny things like tangent inverse that might come up. Gabby, what is minutia? Like the little tiny fine tuning, like fine print, kind of quirky sort of things that might come up. Does that make sense? Like you guys.
Can we just kill all these?
No, can we just pause? Pause. 1 year it was biscuits and tea. 1 year it was a gravel processing plant. 1 year it was snow coming down in a piecewise function and she was trying to shovel the snow. 1 year it was something similar to the amusement park. This year you guys had a water one, but it wasn't like a water in, water out. It was something else with a water depth. But there's been water in, water out. 1 year, last year it was the funnel problem, but it wasn't an in-out. The B's was just, I need you guys to get away from the B's and just realize it was an in-out problem.
Yeah.
It was an in-out problem. Like classify it in your mind and be like, okay, whatever, B's, fine, in-out. And then think through what have they given you. That's where I need you guys to be able to step back from the, however weird it sounds in your head when you're reading it. Be like, wait. There's nothing new, no new theorem I need, no new like knowledge of B's, you know? Like, you just need to see the calculus in it and what you're supposed to do. Does that make sense?
Quickly do B's multiply. I need to know the rate.
Anyway. But actually, what? Anyway, so.
What's their life expectancy?
Alright.
So I know how big these are.
Okay, I don't want to waste any more of your time. corrections that need to be done, and they're technically due tomorrow by the end of the day. Stop! I'm giving you half an hour in class, and you would just let us get stuff done. So work on it. Today's a work day on your corrections, but first, for all the random talk about bees, but first, why am I scrolling? P.S. Starting tomorrow, maybe the day after, we're gonna actually go topic by topic, and we're gonna have some nice intro and then some multiple choice. But why am I going right now, skipping way ahead and going to a problem like this?
Because we probably all failed that on the test.
No, I haven't graded them all.
Oh.
But I did a quick sampling of the first 15 turned in, and I was like, okay. I'm not saying you're wrong. I was just a little discouraged. On Friday, I showed you something like that, a differential equation. Yes, that's what this test is on. I showed you something like this, a differential equation. And I said, not that every single problem has this, but if you're given, you should go looking through the answer choices saying, does one of them say find the particular solution y equals f of x, g of x, h of x, I don't care of x. Nope, that's sketching. What is, oh hey, look, it's part C. Not that one, find a second derivative and plus a differentiation. This one, what is the particular solution? As soon as you see them say find or solve for, or what is the particular solution, it might not be there. It might not be there. But if it is, you say, 3 points. If you start the problem. Some of you had a mental block by this point on Saturday, so you were just, who knows what was going down in the paper, you didn't know. I won't know, no one will know. But hopefully, you got the experience of, this could get overwhelming, and I need to be able to pull myself out of the questions I'm being stuck on. Maybe order the FRQs and look through and say, I like that one. I don't mind that one. Ooh, that one will be bad. I'll leave that one till the end. Maybe you should do them in different orders than 3, then 4, then 5, and 6. But long story short, hope we get to the point where for letter C, if we have dy dx is equal to, hold on, I forget. So 3x over what? And you see the wording, find a particular solution. What is the particular solution? And you see a, you say, I need to start by moving what? I told you one thing to move always first. No!
Yes, yes.
Always move the dx. I promise you. I've done this for a long time, and a lot of you get confused if you don't start there. Move the dx.
Move the y.
And say, who doesn't belong? Then move the y. And say y dy is equal to 3x dx. Pause. Show your work. What do you want to do to keep going backwards from a differential equation? Show your work. Integrating. Hey, that's a point. You just started the problem. This is another point. I'm not going fast. That's another point. That's another point. Almost always. That's another point. Almost always. So far, you've gotten 1, 2, 3, 4, and you haven't even used your or gotten y by itself, which are more points. If every single one of you, 1, 2, 3, 4, could get 4 out of 9 at least on every single FRQ, it would be the best year of AP Calculus, really, that I've ever taught. Now, do I hope you get higher than 4 on some? Yes. But I'm saying, if you guys couldn't get at least a 4 on every single FRQ, you'd at least have a 3 on the exam. Probably even a 4. If you don't skip the multiple choice section, actually try. Coming back. Could we plug in x is 0, y is negative 1 right now?
Yeah.
And find a c? And plug in that c? So how do we have to finish the problem? So could we get y by itself right now? And then plug in c? And then plug in c? And then plug in c? Whichever route you take, make sure you show the plugging in. What if you're like, I don't know how to integrate? Make up something and put a plus c and put in a point and say, oh well, hopefully they give me those, and they will. But you shouldn't really have to guess what to do. Move the dx, figure out who doesn't belong, move them to his proper side, have your little expressions ready for integration. Kiddos, on this test, let's see, that was number 1, kind of number 2, although number 2 they did the problem for you. Did you hear in the interview where they said, I notice sometimes you do all the hard work or all the minutia and just have them apply it, use it, explain it. That was number 2 on this test. Number 3 was, oop, it was that. Number 4 was, oop, it was that. Number 5 was solving an integral. Number 6, 7, 8, 9, which was A, B, C, D, was like matching. Number 10, it was that. Number 11, B, it was that. And number 12, well, letter C, it was that. How important is this topic? So let's correct what we did wrong. Let's work on our weaknesses and let's grow. Sound good?
Sure.
Okay, is this a safe environment? We're allowed to grow. Yuki, come on down. Tom, come on down. Yes, these are the A's. Dylan, come on down. Noah, come on down. John Reeves, come on down.
Yeah, let's go, Reeves.
These are peasants from yesterday.
I'm sorry.
Yeah, come on down. Josh Watson, come on down. Kyle, come on down.
Oh, these still the A's?
Yep.
Oh.
Tasia, come on down. Kelly, come on down. There were other good ones, but for right now, I apologize. Those are all A's. Oh, those are good ones. But once again, I'm too proud of you wherever you are. If you worked your hardest and your best, and you were willing to grow today, and in no particular order, Eason, Jacob, Andy, Carla, Jeremy, Claire, hold on, I missed someone. Amy, Claire. Eason's gone? Andy's gone? Remember, this was with the +7. It's already been added in.
Oh no.
Jeremy's gonna hide you. Emily, Cameron. Irene, Josh, Caitlin. Josh Wayne, Caitlin, Bree, Lucy. Chris, Warren, Gabby. Madison. You're gone. This is the highest grade of book. Kiddos, pause! Problem by problem. Stop reacting and start saying, hey, there's a weakness. Alright, let's work on it. Wait, no, what did I You know that. If you guys have questions, raise your hand. If you want to move around and work with someone else, alright, fine, you can move around, but just stay productive. Otherwise, if you guys have, test correction paper. You guys have pass. Oh wait, yours didn't help. As you guys are working, pass forward. First of all, your 2016, if you have it ready. It's due by the end of the day, but 2016, pass it up to me. I'm just trying to help out and keep it all nice and good. Just 2016. Any more? Camera, look behind you, crap. No, look. Just 2016. No big ones on top.
I didn't. Hit it again. Yeah.
Any more 2016? Any more 2016? Alright, 1 through 6, pass it up. I've heard you practice. If they're ready, pass it up.
Reeves.
Oh, you're just reading it? Any more 1 through 6? Any more 1 through 6? You will get out what you put in, guys. Take time on these corrections. Ask me, ask others. If you're not sitting next to someone you feel comfortable asking, move around to someone else. There's some great kids in this class, and there are others, they're all right. At least they're smart. Okay, so. Just kidding. That's how my friends feel. Any more? Oh, I thought I had one more.
I don't even have
Wait, pause. We're working on corrections. We're not worrying about other stuff. Power on? No, you do have to plug in. I was just saying you were wrong because of that mistake. Oh, sorry. All right, go to somewhere where you don't mind asking questions. I'm right here. Hopefully, you don't mind asking me. Wait, what? What?